Hello, and welcome to this film about making standard solutions. It's the first of a number of practical films, which I've put in the acids and bases topic, but these techniques are just as important in the redox topic, really. Okay, so although these films will concern an acid-base reaction, it's important to realize that these techniques are not confined to the acids and bases topic. Okay, so hopefully by the end of this film you'll know what we mean by a standard solution and how to make one, so you'll know what equipment we use to do it, and also you'll know what steps are taken to try and make sure that this procedure is as accurate as possible. Okay, so we're going to start off by taking a substance called a primary standard, and we're going to accurately weigh it out. Okay, so I'm going to be using anhydrous sodium carbonate, which, as you'll see in the next film, is a good primary standard. I'm using a 250 ml volumetric flask to make a 0.1 mole per litre solution. So in other words, I want about 0.025 moles to be in my flask. Now, weighing this out accurately is not about getting exactly that number of moles. It's not about weighing exactly 2.65 grams of sodium carbonate, which would be 0.025 moles. But it is about knowing accurately how much I've taken. Okay, so I'm going to try and get somewhere close to 2.65 grams, but I'm not going to worry if I don't get it exactly right. What I am going to make sure I do is I'm going to make sure I know the mass that I've taken exactly. Okay, so that's what weighing something out accurately is about. It's not about taking an exact amount, it's about knowing exactly what amount you're taking. Okay? So if we have a look at how much I've weighed out, I took 2.49 grams. And then we're going to take that substance, which often we've already weighed out, in a beaker, but if we haven't, we'd put it into a beaker and dissolve it in distilled water. We're using distilled water here, not tap water, because we don't want to add any impurities. Now, I just need to be a little bit careful here when I dissolve the substance in water, partly because I don't want to splash the solution around, because that will end up causing me to lose some of my substance, but also because I need to be aware that my volumetric flask is only going to hold 250 mils. Now, I'm going to need to rinse this beaker in a moment, so I need to try and dissolve the substance in quite a lot less than 250 mils of water, so that I can make sure that all the solution that I make and all the rinsings are going to fit in my volumetric flask at the end of this. And then we're going to transfer our solution to a volumetric flask with rinsing. Okay, so we're going to make sure that our equipment is thoroughly rinsed so that every single last bit of the solid that we weighed out ends up in the volumetric flask. I'm just going to use a funnel in the volumetric flask to make it a little bit harder to spill the solution everywhere. It's worth noting that this volumetric flask ought to have been rinsed with distilled water before we do this. You wouldn't rinse it with a solution of the sodium carbonate, because that's going to change the concentration of the sodium carbonate that you're putting in, but rinsing it with distilled water isn't going to do any harm. As you can see, we're putting plenty of distilled water in here. We're making sure that we rinse not only the beaker but also the glass rod and the funnel that we've been using, so that we're making sure that every last bit of solid ends up in the volumetric flask, which, remember, should have been rinsed with water before we started. Okay? And then we're going to add distilled water to our volumetric flask up to the line that we can see on the flask. Okay? And then we'll make sure that we've got a certain volume of solution. So this is called making the solution up. Now, all volumetric flasks will have a line on their neck. What we're trying to do here is just really carefully with the distilled water top up our solution exactly to the line, meaning the bottom of the meniscus is resting on the top of the line. And then the last stage, which is actually a lot more important than some people give it credit for, is to invert the flask and make sure that the contents are fully mixed. Now, the reason this is a really important step to do is because the solution doesn't mix very well whilst you're doing your rinsing. So putting the stopper on, holding it in with your finger, just turn the flask right upside down a few times and give it a swirl while it's upside down. Shaking the flask up and down does not do a good job of mixing. And that's about it, really. That's how we make a standard solution. So make sure you remember those steps. Make sure you understand why we're rinsing things and how it is that we're trying to remove inaccuracies from our procedure.